Hello. Can everybody hear me? Great. Okay. Hello. Welcome. Congratulations on joining First Local Cat Savings Bank. It's your first day, and we're so excited that you're all joining us here in our new office in Berlin to bring this next generation of savings accounts to our customers. So you might be wondering, why did we hire all of Swift developers? We believe Swift, we love Swift, and we want it to be everywhere and used by everyone. Our entire banking platform is built on Swift, which is why we've hired all of you to join us. So this is a brief induction session to basically look at what we build and go through step by step how we build things. And finally, we're going to take a look at the company culture and the future that we see. So let's start by looking at what we build here. So you might not all be familiar with it. So this is our original savings account 1.0. It's very cute, right? The customer puts their deposit on top of the coin bank. The coin gets brought into the savings account by the cat, and then the money is deposited into their savings account. Now, our customers have loved this product, but they want something a bit smarter. There's been a lot of feedback, some frustrations from them. They want to know how much money they've deposited. They want to know how much is in their savings account. And they want to be able to access this information from anywhere on their phone. So I'm very excited to introduce to you our brand new product, the very cleverly named Smart Deposit Platform. So let's take a look at how this works. So we have our existing savings account, and our new Smart Deposit Platform sits below the existing savings account. And the same kind of thing, the user puts their deposit on the bank, the cat comes up, takes the money into the account. The user then knows how much money they've just deposited, and they also get notified what their balance is. And then this all works by talking to the iOS app so they can access their account information anywhere. Cool. So what's under the hood of this? Like, what's powering all of this? From a high level, we've got kind of three main parts. There's the Smart Deposit Platform, and that's the hardware, which we'll go through in depth in a bit. Then there's the kind of cloud server side, and of course, the iOS client. So the Smart Deposit Platform is basically responsible for when the user makes a deposit, it counts it, it calculates the value, and then uploads this information to the server. And then we have the cloud. So this maintains the customer's account information, it tracks the deposit information, and basically account overview maintenance. So I mentioned earlier that our banking platform is based on Swift. So the physical hardware is powered by Raspberry Pi, which supports Swift. The cloud is Katura, which also supports Swift. And of course, the iOS app is in Swift as well. Now, let's take a look at how we can build this step by step. I hope you don't mind gifs of cats. There's a few. Okay, so our first step really in getting into developing this hardware is to set up our development environment. So it's a little bit different from the Mac and Xcode. And the first thing we'll want to do with our Raspberry Pi is to install Swift. There's a really fantastic group of people who are involved in the Swift for ARM community, and they're making sure that Swift runs on different ARM devices. So you can run the script that's at the top, and then once that finishes, you can do sudo apt install, and then the version of Swift. So I've left that out because it kind of depends what Raspberry Pi you're using and what version of Linux you're running. So you can get the exact version from the swiftarm.com. Okay. So we've got Swift installed, now we want to start building things. So for this, we're going to basically run Swift package init -- type executable, and that will create a bunch of files for us to use, including things like main.swift and package.swift. So package.swift, I'm not sure how many of you have used the Swift package manager. Show of hands. Okay, cool. It's for managing dependencies. It's very simple. There'll be some examples as we go through step by step. Now for the Raspberry Pi, so the reason why we're using a Raspberry Pi is because our hardware involves working with electrical components like sensors and a screen. So that's why we're using a Raspberry Pi, because it has these pins, these GPIO pins. GPIO stands for General Purpose Input-Output, and it's ways of getting data in and out of components and things. So on the picture on the left shows a Raspberry Pi, although much bigger than they are. They're only about palm-sized. And then I've highlighted where the pins are on that. Now, if you're building a kind of more complicated circuit, or your fingers aren't very, very small, working directly with those pins is difficult, so you can actually just get kind of like a breakout board. So the picture on the right is this breakout board that gives you a little bit easier access to the pins and also lets you build kind of more complicated circuits. So what do these pins do? What are they? This is a diagram showing the different pins on the Raspberry Model 3B+. And it has a total of 40 pins. Some of these are for power. So there's 3 volts or 3.3 volts and 5 volts. And there's a couple of ground pins. So these help you basically create a circuit. And then the GPIO pins are the ones where you can actually send and receive data from. Before we look too deeply at the components that we're using and how to actually support them, we need to be able to communicate to the pins. So we're going to use a library called SwiftEGPIO. So this is our package.swift file, so we can add in the dependency here. So we add the package, the URL for the package, and then add the dependency to our target. So once we have this and we build it, we've got everything we need to start actually communicating with hardware with Swift. Now, also to mention, you're not limited to only using the Raspberry Pi. Pretty much anything that is ARMv6, 7, or 8 will work, mostly. But these are the ones that definitely work. So if you have any of these and you want to try it out, go on. But yes, lots and lots of support for different boards. So we've got our Raspberry Pi ready with Swift, and we've got a library so that we can start talking to the pins. So now we'll start digging into how we actually make this smart deposit platform. So the first part we'll look at is showing the deposit status. So for this, we're going to use this little LCD screen, the very nicely titled HD 44780. Rolls off the tongue. So on the left here, we've got the actual component that we'll be using, and on the right, this is like a wiring diagram, how we need to actually hook it up to the pins on the Raspberry Pi. And then also the lovely person who's made SwiftEGPIO has also made a lovely little class for working with this LCD. And so if we hook everything up, it starts looking like this. So if you ever complain about spaghetti code in your code, welcome to physical spaghetti code. It starts getting very wiry. Yes, so we'll hook this up. And then to work with it, it's actually quite simple. So we'll import SwiftEGPIO and our LCD library, and then all we need to do is initialize SwiftEGPIO with the type of Raspberry Pi we're using, set the pins up, and then we create an instance of the LCD, and then when we're ready, we send it the characters that we want to be output. So very simple, very straightforward. Okay, so with that working, we want to know what coin the customer is depositing. So we want to calculate the value of the coin that they've placed on the platter. And we can do this by thinking, well, each coin has a unique weight, so if we can determine the weight of the coin, we should be able to determine the value of the coin that they've put on there. So we can do this by thinking, well, how much does the current savings account weigh with the coin on it? And then if we subtract the value of the weight of what it was previously before the coin was put on top. So for example, that might be like currently our savings account weighs 1,003.5 grams, and previously it weighed 994 grams. So if we subtract the two, we get 9.5 grams, which is a 1 pound coin. I apologize, I didn't localize this into euros here. I operate in pounds. Cool. Okay, so we know how to calculate the value of the coin, but how do we actually weigh the coin? Well, for this, we're going to use something called a load cell. So the picture on the left is the actual component for a load cell. It's this metal bar with these wires coming out of it. The picture on the right is our CEO doing a bit of beta testing with the load cell. So what is a load cell and how does it work? So it's this metal bar with the wires, as I said. And basically, as you put a weight down on top of it, the load cell kind of bends. Not really this much, this is exaggerated so that you can see that it's bent. So if we look closer, what's actually happening is inside that bar is a bunch of little wires. And so when it bends, the wires bend. And this bend in the wires causes a change in resistance. And that change in resistance is how we calculate the weight of something. It seems kind of complicated, but don't worry, we'll look at it a little bit closer. So that change in resistance gets fed out to a little analog to digital converter, so the HX711. It's quite small. It looks big here, but very small. So unlike the lovely LCD library that we had before, we don't really have an easy way of working with this analog to digital converter. So we're going to need to figure out how to work with it. And for that, we're going to consult the data sheets. Yeah, you can feel the excitement in the room. Data sheets. Whew. They're like the instruction manual for the components. They explain what it is, how to use it, everything that you probably don't want to know, but so features, specifications, block diagrams, pin descriptions, assembly code, and also a reference driver. So this actually tells us what kind of code we need to use to communicate with the HX711. So this is, in essence, what this is doing is something called bit banging. Bit banging is basically where we use software to directly set and sample the state of the pins in order to get a usable signal. Okay. So I'll take a step back from there because I didn't really explain about the Raspberry Pi only works like these pins, the GPIO pins, only work with a digital signal. So basically it's on or off. There's no other option. So comparing that to an analog signal, you can have any value, right? You could have 768 or 140 or even negative numbers. So, I mean, a weight is going to be something other than 1 or 0. So how do we take this kind of more complex number and break it into ones and zeros? Well, you can start by looking at the binary representation of these numbers. Then we at least have it in a form of ones and zeros. So that seems like, okay, well, maybe that will work. And we try. It doesn't quite work because we can only send one number at a time. So how can we kind of solve this, like, what is the whole number issue here? So for this, we need to agree a word length. So a word length is basically the number of bits that make up the word. So in this example, there's 12 bits, so it's a 12-bit word. So with this agreed number, this word length, we'll know that we've received the whole number from the HX711. So now we can send each bit one at a time until we get the whole number. I'm not going to go through every single one, because that will take a while. Okay. So If we jump back to the beautiful reference driver written in C, we can see this for loop here. And this for loop inside says, well, up to 24 items. So that gives us a hint that, well, the word length is 24 bits. Cool. If we go inside the for loop, this is where we see the kind of bit banging. So we're pulsing the clock on, we're reading a bit in, and then we're pulsing the clock off. And as we do this 24 times, we eventually get the whole number. And then at the end, there's this kind of weird looking thing. It's like, oh, what's that? So this is getting 2's complement of the number. So when you're working with binary numbers, if you want to represent a negative number, it's a little bit more complicated. So basically the first bit in that word determines whether it's negative or positive. So if it's a 0, the number is positive. If it's a 1, the number is negative. So if it is a 1, you have to flip everything, all the bits, and then you get the number negative. Trust me. Yeah. But yeah, so working with binary, very simple in Swift. So we'll take a look now at how we actually do this in Swift, working with the HX711. So the first thing we're going to want to do is set up our pins. So we'd already set up Swifty GPIO in the earlier example. Now we just need to set a pin for the data. So we're using pin 5, and then for the clock, we're using pin 6. And then, of course, it's important to set the actual direction. So for the data, we're sending, we're taking data in, and for the clock, we're sending data out to the clock. Cool. And this is a rough example of basically how we would take the C driver and write it in Swift. So yeah, that same kind of thing. We go through 24 times, pulsing the clock on, reading a bit in, pulsing the clock off. And then if the first bit is a 1, we flip it. And then at the end, we have, hopefully, a value. And then once we have the value, we can determine, once we have the weight of the coin, we can then calculate the value. So this is a pretty rough example. It can be written much, much nicer in Swift. But basically, figuring out which coin it is based on the weight. Okay. Now, once we know the value of the coin, we can then create like a deposit entry struct. And we'll use this later when we look at Katura. But this is how we're going to save our deposit information to the server. Just note that it conforms to Codable, because this is how everything is beautiful in the world of Swift on all platforms. Okay, so we've built this pretty gnarly looking thing. And this is an overview. So this is we've got the load cell and its platforms. We've got the Raspberry Pi. We've got cables everywhere. We've got the LCD and the HX711. So then kind of making it a little bit prettier. It could still be a little bit tidier, but it's basically what it looks like all together. Great. So then there's the cloud, web, and iOS. And this is what we're going to look at for kind of how this becomes quite powerful. And this isn't a talk about Katura. That in itself could be an entire talk. But I just wanted to give a few highlights of how we're using Katura in this situation to give you an idea of the power of using Swift across all these different platforms. So not only is there Katura, so that's kind of the server side. Katura Kit is the client side framework for sending the HTTP requests to the Katura server. But basically, these two things send and receive, so the server and the client send and receive instances of Swift types directly. And then you can share it, and it's all like holding hands and skipping in rainbows. So this is a short example of what we would do to actually send the deposit to the Katura side from the Raspberry Pi. So the top one, very simple. We just do a post, and it goes. there is some more code, but from from a high level, like you're just sending an object. It's amazing. And then on the bottom example is kind of what we would use either on the Pi or on iOS for getting the deposits from the server. So how many of you, out of curiosity, have integrated like a third-party or internal API, like web API, into an app? Yeah. I think kind of gone are the days where you don't have to integrate something with the web. But generally, it's like tons of code, isn't it? If you want to be able to say, oh, here's my object that I want to upload, and then getting objects back. It's lots and lots of like processing and figuring out and checking types, and all of that just goes away when you start using something like Katura. Cool. So there is more code involved, but from a high level, that's basically how Katura and KaturaKit work. And there's tons of other little like things that IBM have done with it. It's very cool. Yes. So now our users can put a deposit into their savings account, and it all gets synced up to the cloud, and they can view it on their phone. Cool. So I also wanted to touch a little bit on the company culture and the future of the company. So I touched on this briefly at the beginning, but we believe in Swift. We think it's a great language, and we want it to be used everywhere by everyone. We think that the more people using it, the better the language will be, and that ultimately the more diverse our community will become. The world is full of so many different types of people from different situations, different backgrounds, different thinking. But if we only have a small subset of people kind of working in technology and ultimately teaching computers how and what to think, the results are very dangerous. And there's lots of examples. I'm just going to go through a couple. So this is an example of how voice assistants respond to verbal sexual harassment. So when you read through these responses, you can tell that the people on the teams who wrote this are not very diverse, right? They haven't experienced verbal sexual harassment themselves, and ultimately they're normalizing this type of behavior for millions of users around the world. And it might seem like a harmless thing to say those kinds of things to a voice assistant, but it does condition you to think it's okay to talk to other humans like that too. And this is an example from a few years ago. I apologize for the profanity, but it is effed up. So again, you can tell that the team at Google who are working on this AI for basically categorizing and understanding what's in a photo had zero diversity, like no racial diversity in their team. Otherwise, they would have caught this. So do we want to enable this kind of technology? Is this the future that we want to create? Do we want to alienate people? Do we want to make them feel like they're less worthy, less equal? So Swift is still relatively new, right? It's a few years old, but it's changed a lot over the past few years, and thanks to the community involvement. But the barrier to entry is really high still. Like, for the most part, most people who do Swift development are on Macs, and Macs are kind of expensive. Like a Raspberry Pi, for example, much cheaper. The cheapest model actually starts at $5, €5. So it really lowers that barrier to entry. It makes it much more financially accessible for people. But what I didn't really cover earlier is the tooling on Linux is a bit poor for Swift. So although there is full Swift support, it's not like we have Xcode on Linux. That is at the top of my WWDC wish list. I don't think it will happen. So I want you to take a moment and really think about, what do you think Swift will look like in 5 years? And don't think just about the language, but what will the Swift community look like? Where will Swift be being used? So I kind of see two futures. One where we kind of continue on the path that we're going, where it's really just people who work kind of within Apple platforms and maybe a few other kind of strange people who go, yeah, Swift. And that we keep going down this path. But I also see this other future where Swift is everywhere and is used by programmers across the world, across many different domains, and that it's actually more popular than Java. Because Java is actually currently ranked as the most popular language at the moment. Now, I actually don't mind Java that much. So really, if we look at this first future, if we keep going this way, it doesn't look like we're creating a language or a platform for people other than ourselves. We won't have this diversity that we need to have a good future. We won't be actively bringing new people in. So future two, though, this everybody using it everywhere, it being the most popular language in the world, how do we get there? What do we need to do? There's so much that we can do to grow Swift. Start by asking yourself, what can I do to help build the community? What tools can you create or contribute to? File radars with Apple, get them to do Xcode for Linux. Who can you teach? And ultimately, what can you do to help Swift evolve? So it's a very exciting time to be working with Swift, Swift in hardware, Swift on the server, Swift on iOS, Mac, all of that goodness. But it's still a relatively new and unexplored area. There's still lots of room for improvement in tooling and libraries. We need pioneers. We need people to come and set up the infrastructure so that more people can use it. So I want to leave you with these two questions. The first one is, what future do you see for Swift? And the second is, what can you do to get us there? Thank you.